You can't just put all your enterprise data into ChatGPT and send it off to OpenAI. If you asked a question in Spanish, you can search over, say, documents that are written in French. The response can be prompted to come back in English. So you can have like a trilingual conversation in one go.
Rather than taking data to the AI, we are taking the AI to the data.
North is the platform to be able to easily build these agents. It's a fairly low code environment. We might read a book and we skim through all the pages, but that's not the most efficient way for computers to be able to search for information.
3 words summarize everything that we covered in the podcast, right?
I go sovereign, multimodal.
Isn't multimodal 2 words? It's all right.
Oh, come on.
G'day, everyone. Welcome to another episode of Decoding the Future podcast. I've got Andrew Garkic with me today. Welcome back, Andrew. You're almost becoming a regular in the podcast.
Thank you, Mahesh. It's an honor to come back.
Today, we're going to be talking about Cohere and enterprise large language models. You know, models these days, Andrew, are coming out faster than your team goes out for coffee runs, I hear.
Yeah, it's wild.
Cohere operates in a very niche space, I suppose, more enterprise large language models. So how does that fit in with the regular LLMs?
Yeah, I mean, let's think about if we take, you mentioned coffee as the example. If you go to ChatGPT, you might say, which city has the better coffee? Is it Sydney or Melbourne? We're here in Sydney, but I know you're from Melbourne, so it'd be interesting to see what it has to say.
If the large language models say anything other than Melbourne, I seriously question the data it's been trained on.
I'm not sure.
So what about the enterprise context?
Yeah,
then?
so if we try to think of this as in an enterprise context, it'd be like, maybe I took the team out for coffee and I want to expense a claim for, $100 for the coffee, but I don't know what the policy limits are. So we'll get a chatbot to go look up the policy documents, and then I'll then understand how I can submit that claim.
$100 for a coffee? Man, I really want to know what kind of coffee your team is drinking.
Hey, we've got fancy coffee here in Sydney.
Okay, well, jokes aside, I think let's talk about 3 things today. We'll cover what enterprise large language models are, right? Just dig a little deeper into that, and then double click on that. We'll talk about Cohere, because Cohere is a company that focuses on this. And I know a lot of people know more about OpenAI because of ChatGPT or Anthropic and things like that. So we'll talk about the company a little bit.
Yeah.
And then we'll talk a little bit more on the use cases that people can actually use it for.
Yeah, sounds like fun.
So Andrew, what are you seeing in the enterprise space when it comes to large language models?
Yeah, so if you think about ChatGPT, you go to the app and then you might ask a question, and it'll go to the internet to get information.
Yeah.
But where we're really seeing the value in the enterprise context is being able to take that same level of intelligence, but with enterprise data. The challenge is that you can't just put all your enterprise data into ChatGPT and send it off to OpenAI. So that's something that we're trying to tackle with.
Yeah, so the example that you're talking about earlier, the coffee example, right? How do you claim for the coffee expense all that is in the policy documents within the company?
Yes.
Obviously, the internet doesn't know anything about it. So you feed the data from the enterprise, like all the documents and everything else, and you ask the question.
Yeah, and so today you would need to, if you wanted to use ChatGPT, you'd need to get that PDF policy document, upload it into the chat window, and then have a conversation with that. But we're trying to find more value to be able to do that in a more secure way in that enterprise context.
Okay. So let's talk a little bit about Cohere. Now, Cohere focuses on the enterprise large language model space. It's a company that was founded in 2019, so they've been around for about 6 years. They got funding for about $1.6 billion, I believe, and I think they're currently valued around $7 billion. Like a lot of these companies, I mean, they're valued quite highly. Fujitsu, interestingly, has taken a stake in the company. We've got a small stake, but along with the likes of NVIDIA and Oracle and everything else. But more importantly, we've also signed a strategic partnership with them. So we do a lot of work with them.
Yeah, and their CEO, Aidan Gomez, he was actually one of the authors on the first paper. It's called Attention is All You Need. And that was sort of the foundational paper for large language models, and then went into building Cohere.
Well, what's interesting is I know a lot of these companies are based out in the US. Cohere is actually a Canadian company. I think they've got headquarters both in Canada as well as in San Francisco.
Yes.
So they've got slightly different to some of the others. So Andrew, let's talk a little bit of the problem space itself. What are the problems that we're trying to solve over here when you talk about enterprise large language models? I know you spoke about RAG and everything else, but what else are we trying to solve?
So if you think about the regulated industries, defense, state, federal government, we were talking earlier about data having to be loaded into ChatGPT. That's something that definitely cannot happen. And so a big concern when we're talking to these sorts of clients is privacy of the data and the security of the data, but then also the sovereignty of the data. So these are all the sort of things in play that we're having these conversations. There's things around compliance requirements, GDPR, privacy, security. They want the capabilities, but at the moment, the offerings are in the public cloud. And so that's the challenge.
So of course, enterprise large language models doesn't just bigger models. They focus more on security, compliance, and so many other things. Now, this is one of the reasons that I told you about the strategic partnership that we signed up for the strategic partnership. We then used it to build a model on top of Cohere called Takane. I'll talk about this a little bit later. But I want to jump in and talk a little bit about some of their models itself.
Yeah, sure.
So let's touch on that.
So they have a whole family of models. They call it the command family. And so initially they started with command R, I think it was, and then they had command R plus, and then they had command R7B. There's all these different iterations.
It's very similar to OpenAI's GPT.
There's like 3.5, 4, 5, GPT-5.
We lost
count. Yeah. And they come out, as you said earlier, they're coming out so quickly. So, but the latest, their flagship model at the moment is command A, and that's really built for the agentic age, being able to sort of plan and use tools. But I think a bit of a differentiator for Cohere is that they've also got models in the embedding space, and so they've got a model called Embed 4, and then they've also got another model called Re-Rank. And I'll try and unpack what these things, why these models are valuable, and why it's different to, say, OpenAI and Anthropic. Because a lot of the big frontier companies are pushing those models for that chat or software development coding interface. But Cohere is really focused on enterprise. The value of enterprise is connecting to enterprise data, as we discussed earlier. So there's this terminology called RAG, which is called Retrieval Augmented Generation. And what that means is that if you ask it a question, say we're saying, how do I claim my coffee? It needs to go and retrieve information. Once it's found the relevant information, bring it back to the large language model, and then the large language model has to give its answer back to us. So when we get all of that enterprise data, we need to put it in a certain format that the large language model can search it and understand it in an efficient way. We might read a book and we skim through all the pages, but that's not the most efficient way for computers to be able to search the information. So what the embed model does is it converts all of the characters and text in unstructured documents and turns it into a whole bunch of numbers. And then they use, these shortest distance calculations to find the most relevant bits of information. So the embed model translates text into a whole bunch of numbers. Re-rank is once we've found, say, the top 5 most relevant pieces of information from that search algorithm, there's another model that will just sit over the top of that and look at the question that got asked and say, based off this question and based off these 5 most relevant documents that we found, can you rank them as to what's going to be the most useful piece of information for the question? And so those are sort of 2 additional models that Cohere brings to the table.
So one other thing I want to add to that is that Embed is also multimodal. So the current model is multimodal. So we're doing this.
And multilingual for that matter. We'll talk about that too.
Yeah, we'll talk about that next. But the multimodality is around basically interpreting images and everything else. So we're doing some work with a company in Europe. So they've got these really complex schematic diagrams and everything else, right? Engineering drawings. And it's able to interpret all of that stuff when, field specialists go into the field and they're looking for something or where like a certain nut or a bolt goes in, it's able to figure it all out. So it's very, very powerful.
Yeah. And I think the ability, so as I was saying earlier, we take those, the text in a document and we convert it to numbers. As I forgot to mention, the big part for Embed 4 is that you can take images in those documents and also convert that to numbers. So if I asked a question, say, find me this part manual, and that part had an image associated with it, the translation of those images into numbers will also show up in our search results. The other key part is the multilingual component, is that if you translated, say some Spanish documents into those numbers are universal in language to the computer itself. So it doesn't really matter.
There's one more thing we need to talk about, Andrew.
Yes.
Agentic is all the craze these days.
Yes.
And of course, Cohere have got North.
Yeah, so they've released this agentic platform that you can build multiple agents in the enterprise context. And I mentioned a little bit about earlier about what an agent is. So it's, taking a large language model and then giving it the ability to plan, but then also execute tools. So it might, call an API in an ERP system or something like that. So North is the platform to be able to easily build these agents. It's a fairly low code environment. So you can sort of drag and drop work and build workflows to say, if a question got asked, then go and look at this source system and, execute this tool. And then once you've done that, you can define that whole logic tree for how an agent should behave and what tools it should have access to. And so the interesting part about this North platform is they do provide it on their on Cohere's instance, but then you can also deploy North in the local on-prem environment. So it's a platform that can be used in multiple deployment configurations.
I was just looking at my newsfeed this morning, and there's just an announcement today that Cohere North is going to be integrated really well with SAP. And you're talking about that enterprise use cases and internal ERPs and everything else. I think that's going to get stronger and stronger when they have all these tighter integrations into these tools as well.
Yeah, for sure. And I think another thing when you think about enterprise is, these frontier models, the frontier companies are building these giant models, right, to be extremely intelligent, have high levels of reasoning. But where Cohere's sort of trying to play a little bit of a different game is they're trying to build extremely capable models, yet extremely efficient. So these big, large models in the frontier companies need to be run on giant supercomputer clusters to be able to run. And we've seen announcements of like OpenAI and the Stargate program in the US and all these sorts of things. Where Cohere plays differently is that their flagship model, Command A, can be run on they're called H100 GPUs. And a H100 GPU is sort of the size of like a laptop. Two of them together is the size of a laptop, so it's a game changer in being able to run these models in an extremely low footprint and efficient processes.
Now, I think you cannot understate how important this is, right?
Yes.
I mean, like when you start to run this in your, an on-prem, in your own data center, or some kind of like a hybrid model and everything else, if you want the inferencing to be done in-house, these models need to be efficient. So you can't go around investing, I suppose, like millions of dollars on CPU just because you want to run your AI.
Yeah, and you become heavily dependent on cloud infrastructure. So, for example, OpenAI. If you wanted to access OpenAI in a secured manner, you'd need to go via Azure's Microsoft Foundry. And if you wanted to access Claude's family of models, you need that cloud infrastructure. So they've got partnerships with both AWS through AWS Bedrock, but then it's recently available on Microsoft Foundry as well. So being reliant on those cloud partners becomes a challenge to the enterprise.
And these models they're all run on containers, so you can actually deploy them anywhere, really.
Yeah.
Andrew, one other thing that you mentioned almost in passing is around multilingual capabilities, right? So maybe we can double click on that a little bit on what Cohere's capability on that is.
So one thing that really stood out is that multilingual capability. So like take Command A, for example, that's got 23 languages. And then the Embed 4 model has over 100 languages. So what that looks like as a use case is you could say, ask a question in Spanish through that RAG pattern that I described earlier. That will then can do a search over, say, documents that are in French. And then you can prompt the Command A model to respond in English. So that means you're having this trilingual conversation and interacting with documents in ways that you wouldn't be able to earlier. And a key part to this is that it's not like we're translating all of this information with like an interim translation service. This is multilingual capability embedded at the core of the product. And so that's unlocking, real value if you think of it in a global corporation context.
Company,
they could have policy documents that are in a certain language, but then you would want another region to be able to interact with those documents. The other use cases, if you think of it in a defense context, trying to synthesize intel across the globe becomes a native feature of their
you may have intel coming in, let's say Arabic or Mandarin or Spanish or whatever language that may be, and ability to kind of like ingest all of that stuff or ask questions in English on some of these documents. That'll be crucial for them.
So it's extremely powerful.
Yeah, it knocks everyone else out of the park. I think, look, language is such an important thing. I mean, even in a place unlike Japan, where Australia, a predominantly English speaking nation, I read somewhere that we have like 300 plus different languages that are. I didn't even know there were so many languages to start with.
I mean, we're such a multicultural country, right? And there's so many different languages and different, such a diverse community. Even though we're predominantly English speaking. So this is where these sorts of capabilities in these large language models become so powerful in sort of on the topic of like accessibility. Because if you think of it in like a MyGov, it's a popular website that we all interact to get our government services.
Yep.
Let's say, someone from the Vietnamese community struggled with English, but then they're really strong in their native language. If they needed to interact with MyGov, they would need to find a translator and then be able to get those appropriate services. If we imagine what that could look like with these large language models, they could be going to the website, asking a question in Vietnamese, and through the power of, that embed model I was talking about earlier, it can search over our English documents and the Gov policies and then give the response back in Vietnamese. So it's extremely powerful.
Set aside, multilingual and multimodal and everything else. One of my favorite things about Cohere is the deployment models. It's very flexible. You can deploy it on the cloud. You can deploy it on-prem.
Even
hybrid models,
private clouds,
and everything else. I think that's a really, really powerful thing for them.
It brings up an interesting topic, though, on sovereignty. How do you define sovereignty? What does that actually look like?
I've had several debates, I should say, with people on what sovereign AI really means. To me, there are three main things that we need to focus on. One is the data sovereignty, where the data actually resides. The second one is the infrastructure, where the inferencing is run, right? And the third one is around the talent piece itself, right? We shouldn't, in my opinion, be building our own large language models.
I was going to ask that. Yeah.
Look, for a country like Australia, we predominantly speak English. Western data sets is good enough for us. If we have a company that is actually building a large language model, training and everything else, it is a huge expense for a lot of people to do it. And of course, you got to, it's just not just the training at one time. You got to be iteratively training data. These models needs to get bigger and better. And so it is a very expensive process. So in my opinion, the best thing is to do is like take an existing model, right? I mean, this is what we've done with Takane as well. So we've taken an existing model and we fine-tuned it for Japan's national data and language and everything else.
Yeah.
And that is a sovereign model.
And I think that 100% makes sense in that Japanese context. And, because we're predominantly English speaking, then, aligning with the Western models makes sense. I wonder what it looks like if we think of it in a local context.
Some of the indigenous language.
Yeah. Like, what if we fine-tuned to Maori or to...
Yeah, look, I think that's one of the things, right? Rather than actually train the model from scratch, we just fine-tune it to support languages like Maori.
Yeah.
Or some of the indigenous language. I mean, there isn't a lot of content out there, right?
Yeah.
But the fine-tuning should be good enough for a lot of that stuff.
Yeah. And I think it'd be interesting to see, how these models could understand the culture. That's something that wouldn't be covered that much.
Fine-tuning should help again, I think. Yeah. I know before we wrap up, Andrew, I know we touched upon defense and public sector as like really good use cases. Are there any other use cases that you can actually think about that will benefit from an enterprise large language, like with a sovereign capability and all that?
Yeah, I think if you think, other regulated industries like healthcare, clinical research and the privacy that needs to come with working on that kind of data is where it makes sense to be using these enterprise grade models. Financial services as well, legal contract tender reviews, M&A research is stuff that's extremely sensitive. So having these secure sovereign AI models can have a huge benefit in those areas as well.
Yeah, look, I see a common thread coming through all the conversations, right? I mean, like sovereignty and where the inferencing and all that is done is not like a bolt-on. You cannot like do all of these things at the end of it, decide, how to do it. I think it's got to come at an architecture level, and that is really important. I think the big thing from me is like if you look at Cohere, rather than taking data to the AI, which is what happens in a lot of cases, we are taking the AI to the data. So the data still says where it is, and you're taking the AI and doing it there. Yeah.
And I think that completely changes the conversation on the types of use cases that we can unlock. And I think the technology that underpins that, we talked about throughout this whole conversation, multilinguality, multimodality, these things combined with that deployment configuration of bringing AI to the data unlocks value in markets and industries that it may not have been able to reach.
Yeah, I think one other thing that I'll actually point out is that when you are running, Cohere models like Takane or Command A locally, the initial cost of it could be quite high because you're setting up the infrastructure and everything else as opposed to going to the cloud because everything's set up and you just pay per use and everything else.
Yeah.
But it is the same market when you have security, compliance, and all those things, and trust and all that is like paramount. There's no way around it. I mean, the cost is probably not as important as some of these other things.
Yeah, I think those become critical principles to how different parts of Australian economy needs to run and function, and it's a reality that there's gonna be a difference between having to run this hardware ourselves versus relying on cloud partners. But as I said earlier, those principles are paramount.
All right, thanks, Andrew. Before we wrap up, I'm going to put you on the spot here.
Okay.
3 words summarize everything that we covered in the podcast, right?
Okay.
So people can just take it away.
I guess sovereign.
Okay.
Multimodal, and then multilingual.
Okay. Is it multimodal 2 words? It's all right.
Oh, come on.
All right. Thanks, Andrew. Thanks for your time. And thanks for tuning in, everyone. Until next time, goodbye.